electricity and circuits. An electric cell is a device that converts chemical energy into electrical energy. It has two terminals, positive and negative, and contains chemicals that produce an electric current. When a bulb is connected to an electric cell, the current flows through the bulb and it glows. An electric circuit is a path along which electric current flows. It consists of a source of electrical energy such as an electric cell or battery and electrical components such as bulbs, switches and wires. The flow of electric current is from the positive terminal to the negative terminal of the cell. The circuit must be closed for the current to flow. Electric current flows easily through conductors such as metals like copper and aluminium. Insulators such as rubber, plastic and glass do not allow electric current to flow through them easily. An electric switch is a device that is used to open or close an electric circuit. When the switch is open, the circuit is incomplete and the current does not flow. When the switch is closed, the circuit is complete and the current flows. Wires are used to connect the different components in a circuit. A series circuit is one in which the components are connected one after the other. A parallel circuit is one in which the components are connected side by side. In a series circuit, if one component fails, the entire circuit is incomplete. In a parallel circuit, if one component fails, the other components can continue to function. The voltage of a cell is the potential difference between its positive and negative terminals. The current flowing through a circuit depends on the voltage and the resistance of the circuit. The resistance of a circuit depends on the material, length and the thickness of the wire used. The greater the resistance, the less current flows through the circuit. The unit of electric current is ampere and the unit of electric potential difference is volt. The unit of electric resistance is ohm. The power of an electrical device is the rate at which it uses electrical energy. The unit of electrical power is watt. The electric bill is calculated based on the amount of electrical energy used and the rate at which it is charged. A fuse is a safety device that breaks the circuit when the current flowing through it exceeds a certain limit. A circuit breaker is a safety device that automatically switches off the circuit when the current flowing through it exceeds a certain limit. Electrical appliances should be used safely and correctly to avoid electric shock or other accidents. The proper use and maintenance of electrical appliances help in saving electricity and reducing energy costs. Electric cells and batteries should be disposed of properly to avoid environmental pollution. Renewable sources of energy such as solar and wind energy can be used to reduce dependence on non-renewable sources of energy. Solar cells are devices that convert sunlight into electrical energy. Wind turbines are devices that convert wind energy into electrical energy. Biogas plants are devices that converts organic wastes into biogas, which can be used as source of energy. Hydropower plants generate electricity using the energy of falling water. Thermal power plants generate electricity by burning fossil fuels such as coal, oil, and gas. Activity. Aim. To make a simple switch and use it in an electric circuit to understand its working. Materials required: 2 drawing pins, 1 safety pin or paper clip, 2 wires, 1 small sheet of thermocol or wooden board, 1 electric cell, 1 bulb. Procedure. Take the thermocol sheet or wooden board and fix 1 drawing pin onto it by pressing it down. Take the safety pin or paper clip and insert one end into the ring of the other drawing pin. Fix the safety pin onto the thermocol sheet or wooden board by inserting the other end into it, making sure it can rotate freely. Fix the second drawing pin onto the thermocol sheet or wooden board in a way that the free end of the safety pin can touch it. Connect the electric cell and bulb with the wires. Rotate the safety pin so that its free end touches the second drawing pin. Observe the bulb. Move the safety pin away from the second drawing pin. Observe the bulb again. Observation. When the safety pin is touching the second drawing pin, the bulb glows. When the safety pin is moved away from the second drawing pin, the bulb stops glowing. Precautions. Do not touch the electric cell and bulb when they are connected to the circuit. Make sure the safety pin can rotate freely and does not get stuck in one position. Ensure the drawing pins and wires are not touching each other as it can cause a short.